All right. Next, we have Sebastien Buisson. He's been working on Lustre for 9 years, specifically on SE Linux Kerberos features over the past 2 years. He moved from Bull Atos to DDN last year. He's now part of the Advanced Solution Laboratory, has been focused on Lustre-related security aspects. Sebastien, you know, you rock. Well, I'm really looking forward to this talk. But, I mean, you know, you along with others, but, you know, you were working with CEA and you made those Kerberos patches available. And, you know, that's really helped us with our work. So I'm really grateful for that. Ladies and gentlemen, Sebastien Buisson.
Thanks, Steve. Can you hear me? Yep. So I'm going to talk about a Lustre security feature called isolation today. Okay. First of all, let's begin with a little background of security for HPC systems. Historically, HPC systems in general, and Lustre in particular, were nearly only built for scalability and performance. Regarding security, at that time, we would consider being okay if we had no direct connection from the cluster to the internet, and also if we had control of the physical access on the machine. Things have changed, and it's now very commonplace to have a single Lustre file system that has to support several heterogeneous use cases. Many often, we cannot afford having dedicated resources for each use case. So different populations of users have to share the same file system. But still, at the same time, we must make sure that private data is only accessible to entitled users. Here are the two main security requirements we see for HPC, but also LifeScience storage systems. The first one is authentication, the ability to authenticate who can be part of a Lustre file system. And the second one is isolation. That is to say, the ability to provide an isolated namespace to different populations of users that are sharing the same file system. Regarding authentication, now Lustre supports Kerberos, so it means we are able to authenticate the nodes that are part of a Lustre file system, and we are also able to authenticate the users that access the Lustre file system and the files on the file system. So we already have it. To fulfill the isolation requirement, it's a little bit less straightforward. We want to combine different features, which are containers, Kerberos, and subdirectory mount. By containers, I mean Linux containers. So we want to run Lustre clients from containers. We want to authenticate each container with its own Kerberos credentials. And at the same time, we want that each container is only allowed to mount only a portion of the global Lustre namespace, depending on the client and containers credentials. So what are containers? We use Docker containers. So Docker is just a management layer on top of Linux containers. Linux containers combine two different features. The first one is the Linux namespaces. So this is the namespaces define the execution environment as seen by the applications. So it's processes, networks, UIDs and GIDs, and also mounts. And with containers, you can also control the resources via C groups. So CPU, memory, block I/O, and network. The main advantage of containers compared to virtual machines is that they are lighter, they run on the host kernel, and they are usually made to be dedicated to one application. So why containers? We want to have different populations of users share the same file system, but still isolate them from each other. So the first obvious solution could be to have dedicated groups of clients for each population, but it's most of the time not affordable. So our idea is to dynamically instantiate Docker container images on the Lustre clients, which means that all clients remain accessible to every population, and we can even share the same clients by instantiating several containers on the same hosts. So how do we run Lustre clients inside containers? To be able to mount a Lustre client, you have first to be root. Then you need to be able to load kernel modules. Then you have to add new entries under /proc, and in the end, you need to be able to run the mount command. So for those reasons, we run the Docker containers in privileged mode. And in the end, we have multiple instances of Lustre on the same node. It's like they are not really independent. It's like having multiple mounts on the same node. We've had an issue when running a Lustre client from containers. The problem is that our Lustre client in the container will not use the NID that is defined specifically for this container. So we added a new check in LNet. The aim is that when mounting Lustre from a container, it will check and use the NID for which the network interface is the one defined inside the container, so that we make sure we use the correct NID. Okay, so now we are able to run Lustre, but let's have a look at the performance of our Lustre client inside containers. Here's the description of our test bed. We have a client node with 16 cores, 128 gigs of RAM, and one FDR InfiniBand link. First of all, let's have a look at the LNet performance. So we run LNet self-test, both from the host and the container. As you can see, the performance is really the same between the host and the container. Now we want to see the I/O performance, so we run the IOR benchmark, again on the host and then on the container. As you can see, the performance is really, really close. The performance difference here is only between 2 and 3%. So this is good news. It shows that running Lustre client from a container does not have any performance impact. But we want to go a little bit further and see if we are able to control Lustre bandwidth inside the containers. So here we instantiate 2 different containers on one host, and we run 2 IOR instances independently in each container. You have on this picture the right performance. So we play with the CPU-related Docker options, CPU share and CPU set. And as you can see, they have nearly no effect. But this is normal because both Lustre and IOR are not CPU-intensive activities. So trying to limit CPU usage will not help controlling Lustre I/O bandwidth. There is one particular case here. The CPU set, the performance with the CPU set option is a little lower, but this is not due to CPU, but to the lower cache memory available inside the containers with this option. Here you have the read performance, so the conclusions are the same. We are not able to control Lustre bandwidth with CPU-related options in Docker. One solution to control Lustre bandwidth could be to use the NRS token bucket filter feature. We could use a need-based policy. Because each container uses a different need, we could assign different ratios to different containers and have a control over bandwidth with that feature. Okay, so we are done with the performance. So now we're able to run efficiently a Lustre inside containers, but still we have this need to identify the containers and the Lustre clients running inside the containers. However, Docker containers are considered sandboxes for users. It means they can be root and change everything inside the containers. And still we have this need to authenticate and identify the containers. Kerberos remains reliable in that case because there is one thing that only the security administrator of the cluster can do is to install new and valid credentials inside the containers. So it means that even users are root, they cannot pretend to be others and con the Kerberos authentication. Let's see now how Kerberos authentication works on client side. So you have the Lustre client running in kernel space. When it needs to authenticate, it will call a kernel function called request key with callout information. This request key function will call the request key system facility that is configured to call LGSS keyring. This is a Lustre-specific program that is able to use the GSS API because this code runs in the user space. So it's able to retrieve the credentials and send them back to the Lustre client that runs in kernel space. So this is the way it works in the standard case. Now, if we run Lustre into a container, again, we have the Lustre client code running in kernel space. It will call the request key kernel function. But the problem is that this kernel function has no idea that it was called from a Lustre client that is mounted inside a container. So it will call LGSS keyring in the host user space, which means it will not be possible to retrieve the credentials of the container. So we are not able to authenticate in that case. So we made some modifications in the Lustre code. The most important thing is to retrieve the PID of the container's init process. This information is stored in the OBD import structure so that we can put it along with the callout information when calling request key kernel function. So we have done this work under LU 7845. And here is how it works now. So again, we have the Lustre client code running in kernel space. It calls request key. Again, this kernel function has no idea that we are coming from a container. So it will start by calling the LGSS keyring function in the host user space. But thanks to the PID information that was sent along with the callout information, we're able to change the namespace of the running process thanks to the setNS function. And then we run on the container user space. Now we are able to use the GSS API to retrieve the Kerberos credentials of the container and send them back to the Lustre client. So it enables us to have Kerberos authentication inside Docker containers. So now we are able to run a Lustre client inside a container. We are able to authenticate, but still we haven't tackled the isolation thing. We still need to provide isolated namespace to the different containers. And for that purpose, we want to use subdirectory mount. Subdirectory mount is a future Lustre feature. It will be available in Lustre 2.9. And basically, it's the ability to provide a subdirectory when mounting Lustre. So if you do so, you will have only this subdirectory visibility inside the Lustre mount point. So we dedicate specific directories of Lustre to each container. And we make the containers use the subdirectory mount feature to access their specific data. But there is one more step to go because we want it to be automatic. We do not want the containers to be aware of that subdirectory mount. We want the containers to automatically have a subdirectory mount based on their needs. Here is the description of the node map feature. Node map is foundation work for the UID-GID mapping that will be there in 2.9. And it reads that node map is a policy group consisting of one or more need ranges. So it perfectly matches our goal to have different properties for different groups of Lustre needs. So we decided to enhance the node map feature by adding a file set information. We made some code modifications to be able to set this new file set information for each node map. We have pushed this code into LU 7846. And here is how it works. When the file set information is defined on a node map, each Lustre client that pertains to this node map will be automatically returned the file set when mounting Lustre. So the client does not ask explicitly for the subdirectory. If it does, it will be considered a subdirectory of the file set as defined in the node map. So we will do a subdirectory mount. These are other code modifications that we made under LU 7846. So if we put everything together, here is how it works. We have a container. First, it will have to connect to a Kerberos server in order to retrieve its credentials. When it's done, it will connect to the Lustre servers with the credentials information so that the servers are able to check the client's and the container's identity. Then we use the node map feature to look for the file set information, and we return this file set information to the mounting client in the container. So to conclude with this presentation, we wanted to show that we were able to build a robust security isolation on top of Lustre. This requires combining Linux containers, Kerberos authentication, subdirectory mount, and node map features. We have done this work under Jira tickets LU 7845 and LU 7846. So you can have a look if you want. And that's all. Thank you. Any questions?
Thanks. So, have with subdirectory mounts, you basically isolate what's below, right, from the most of Lustre file system. You isolate from bottom to top. But so the question, do you think it makes sense to actually isolate container from the top when, for example, you list something like a directory containing your containers? Do you think it makes sense to disable normal, regular clients to go into that containers and see what's within?
I'm not sure I catch your point. So you want to, you do not want to separate, so you just have to run in the same containers?
No. So the point is that, so to my knowledge, one of problem in Lustre, as long as it related to metadata, is that it's just too many tiny stuff, and when people trying to do things like listing files, etc., especially using -r to go recursively,
yes.
right? You put a lot of load on metadata server, basically for no reason, because we don't need to know everything in Lustre, right? We just need to go to work in the containers. And I mean, if you let them mount root, normal root, then you would like to isolate containers from everyone else as well, no?
Mm-hmm. Yeah. And in that case, maybe you have to rely on Unix rights or other access control, ACLs, I don't know, to prevent from going too deep in the tree hierarchy, I guess. Subdirectory or containers could not be a solution for that issue, I think.
I have two questions. The first is, what version of Lustre do you need? Like, is there a minimum to do this because of the node map feature?
Both for subdirectory mount and node map features, it has to be 2.9 at minimum. My tests and the patches I made were based on 2.7 something. As you said in the test bed, as you've seen in the test bed, it's NIL pre 3.0 version, so it's 2.7 plus many patches. So apart from those two features that have to be there, because we rely on that, it can run on any Lustre version. So if those features are backported, it can be used.
My next question is, what do users do with their data? I mean, is that mount point temporary? Does it die or is it just like permanent? Or how do they get their data once they have a mount point? How do they get the data they want to manipulate there? Or is it?
In my opinion, it's the security and administrators' responsibility to create an infrastructure on Lustre to have those directories dedicated to each containers, so that they can be used by the containers when they are instantiated.
So someone behind the scenes is setting up, here's where your stuff's going to be.
Yeah,
okay,
definitely.
thanks.
Thank you. I have a question about the network level. Maybe you are using in OFA level. So maybe a container has also some functionality to control to the QoS, something network traffic and security. So what are you using now, and what is the new option, such kind of control of the network level QoS, such kind of security?
I'm sorry.
Ultimately,
Can you rephrase? I'm sorry.
Maybe you are using a OFE delivery in the IP band. Is that right? So Linux container has also have a new functionality was the control of the network level. Yeah. Currently using maybe you share the two container share the only one InfiniBand, same driver. In that case, some security problem are like here. So the Lustre level file system is not realized. So what do you have an option or some idea to control such a security and maybe network traffic?
Yeah, you're right. We can combine that to have even more control. Yeah, sure.
Hi, I had a question about scalability. Do you foresee any issues when there are several thousand directories that you might need to containerize?
We haven't carried out scale-out tests so far. So, but the performance at the Lustre client level is very encouraging, and we think that there will be no, the scalability will be the one of Lustre. There is no reason that we have other scalability issues than that.
Responding to what Alex was saying in the first question, I think the idea of limiting access to the subtree mounts, we can think about it in a different way, and perhaps now that we have subtree mounts, the default mount for normal clients would always be a subtree mount, and either they're all using the same one for the whole file system, or you've got different isolated environments. And only special management nodes would mount the root to have access to the .Lustre, the policy engine, and so on. It could be a new way we use Lustre going forward.
And maybe the node map feature can be, because there are flags on each node map to control, for instance, if it's a root, entitled group, and so on. So,
right, and you could have a whole separate namespace for test nodes or development nodes. It could be interesting.
May you explain why you use a init pid for container identification? Because if you have a restart a container init pid will be changed, you will be need to regenerate a Kerberos roles. But container identified by namespace ID, and it is will be don't change it while containers restarts and migration between nodes. If it.
You're right, we wanted to have something robust, so this is why we wanted to use Kerberos in that case, because just relying on namespace information we consider this not as reliable.
Why? Namespace ID, it is reliable because it is will be identified container itself. But init pid may be changed because container is restarted and new init pid should be created. And pid namespace will be mapped init pid from this container to different host pid. In this case, you will be need different Kerberos rule to identify same container.
It has an administration burden because containers have to be properly instantiated by security administrators. They have to install Kerberos credentials inside.
But it is additional work for administration.
Yeah, sure.
So I think it should be replaced with namespace ID to better works.
Okay.
I don't know if this is an appropriate question. So containers are inevitable because I see everybody is going to be using that, and these features are pretty cool. And what I'm curious to know is, do you envision that we'll be using containers in HPC world, and how they would play? Is that why we are kind of doing this? Do you see that being prominently used, or is it going to be used?
We have use cases. We have customers that want to use containers, yes, for production. And even in LifeScience, some are using virtual machines because they have more confidence in the isolation provided by virtual machines compared to containers. And this work can be completely adapted to work with virtual machines. It's even simpler in the case of virtual machines.
So I saw you used -- privileged within the container for the mount. Were there any other system calls that require privileged capabilities other than that?
Not that I'm aware of. So Basically, I haven't tried, but it would be possible to, instead of using the privileged flag, which gives full privileges to the container, it would be possible to only, because it's very flexible, so you can specify by capabilities, you can specify all the needs you have, so it could be possible to refine that and only give power to just be able to mount Lustre.
Thank you.
Did you consider just mounting the file system in the host and then mapping the subdirectories into the container?
I'm sorry, Robert. Can you say it again?
Sure, of course. Did you consider just mounting the client once in the host and then just launching the containers in non-privileged mode with access only to subdirectories?
Well, there's still the problem to be able to mount Lustre.
Well, the host can mount Lustre, right? But then the container, then in that case, the container wouldn't mount Lustre. They would just be accessing it through a subdirectory from the host.
Yeah. In that case, it would require to be able to share the mount namespace between the host and the container. But yeah, why not? Because by default, when instantiating a new container, you will not share the mount namespace, so you will not be able to see the Lustre.
But you wouldn't need to see the mount. You just need to see the directory, subdirectory. So you wouldn't need the mount namespace, which would be an advantage.
But you wouldn't get UID mapping and root inside the container and things like that, right? So if depending on your application, that's maybe important.
It's flexible, so.
One more? All right. Is that it? No? Yes? No? All right.
Thanks. I was curious on your performance, and maybe back up the slides. If I saw it correctly, it looked like you were getting better write performance in the container than not. I just was curious if you had any comment on that.
Yeah, it can be explained mainly because it's only on a free run basis. Running the same test on 10 runs or 20 runs, we would have a better average performance, and we would end up having the same figures. Okay. Maybe you're speaking about this one. Yeah. So the difference here is only 2 to 3%. So it's not significant. It means for me, it means it's the same. Yeah, there is also this aspect where, so we do not want to be, by running those tests, we do not want to be limited by the server side and by the network side. So it's hard to have the right environment and to make sure that this is only a client-side limitation. So this is why I say for me it's equivalent performance. Yeah.
All right. Sebastien, thank you. Very topical.